From Paris to Shanghai, from New York to Dubai. More used than planes, trains, or even cars, the form of transport that billions of us use every day is the lift. Since its invention, the lift has developed alongside industry and new technologies. Today's cabins have nothing in common with the invention of the American Elisha Otis in 1853. In 150 years, the lift has become a highly efficient and intelligent piece of equipment. At the heart of everything, economic and technological wars, the lift is constantly reinventing itself. To develop the devices of tomorrow, manufacturers have created top-secret research laboratories such as this one, buried 350 meters underground in the heart of a Scandinavian forest. For the first time, our cameras explored the depths of this test center where the latest state-of-the-art equipment is being developed.
There's always competition in the area and everybody tries to be the first to develop new stuff and like confidentiality.
This is where the lifts for the world's most spectacular tower planned for Saudi Arabia are being made. The lift will become the central element of the city of tomorrow. Vertical cities populated by skyscrapers where 85% of the world's population will live by 2050. It will revolutionize the way we travel. We'll reveal the secrets of the future lift that is already under construction.
The cabin levitates, so we have a cabin that does not need a cable. This lift allows us to create all possible and imaginable forms of towers with interconnecting towers.
This lift will profoundly change our living environment, our travel, and our daily lives. In the mad dash for height and speed, how do engineers manage to combine cutting-edge technology with safety? Between high-flying interventions at an altitude of 4,000 meters and the development of technology straight out of science fiction films, immediate boarding for a journey like no other. Board an XXL technology lift. La Défense, to the west of Paris. With 3 million square meters of office space, it is the largest business district with the largest concentration of lifts in Europe. Every day, 180,000 employees rush to the 70 towers around the Esplanade de la Grande Arche. To reach their workplace, all these people go to the most used means of transport in the world, the lift.
All the European capitals, Paris, London, Frankfurt, have a growing concentration of business districts, with people coming out of the metro in waves and creating major traffic peaks.
At 8 a.m., La Défense is at its busiest. For the lift experts, this is a critical time where their skills are particularly tested.
The challenge every morning is to load the towers as quickly as possible.
We have to get 3,500 to 5,000 people in each tower to their destination. Our job is to optimize journey times.
Each of us spend an average of 2.5 days a year waiting for a lift. Therefore, time management is a major issue, and manufacturers have realized this.
Over the decades, we have been forced to find improved solutions to this problem as the number of towers has increased.
Lift experts have been investing heavily in research and development since the early 1980s to optimize our travel time. A real headache. For decades, researchers have struggled with the tricky problem of what they call flow management.
Flow management is a big job behind the scenes, with the aim of solving the complex equation of getting each passenger to their destination floor as quickly as possible.
In order to save employees a few seconds, billions are being invested into the development of intelligent software.
From the moment you press the button, there will be a set of technologies, algorithms that will be set in motion to transport several thousand people and move them around the tower with two goals. The first is that they spend as little time as possible on the landing. The second is that they spend as little time as possible in the cabin. It is the sum of the two that interests us, the so-called time to destination.
In order to reduce this time to destination, advanced technologies are being used with varying degrees of success.
There has been logic, fuzzy logic, neural systems, and since the 1990s, a technology has emerged globally called predestination.
Predestination, a new technology designed specifically for high-rise buildings based on a complex system of algorithms. With this technique, the machine takes over and tells the user which cabin to use. The aim is to group passengers according to their destination to reduce travel time.
You type in your floor on a keyboard and the machine automatically tells you which cabin is being used. So you'll be traveling with other people on the same or neighboring floors. This optimizes both your waiting time and your travel time.
These technologies and algorithms save 30 to 40% of time spent in vertical movement. These few seconds saved will add up at the end of the year and adds up to multiple days of time saved by people.
Business districts around the world are equipped with this system as towers multiply exponentially in an increasingly insane competition for height.
Experts tell us that by 2050, 80 to 85% of the world's population will be urban.
Every day, 88,000 kilometers squared of city are created. There is a real phenomenon of densification, so the only way to go is up.
Last year, 143 towers over 200 meters were delivered worldwide. Height has become a major issue in all megacities, dominated by monsters of steel and glass as symbols of the strength of a nation's modernity.
The term vanity height has been adopted. This is defined as who will have the tallest tower. And that's what we're trying to answer with our technology, the high-speed or high-rise lift.
This race for the world's tallest skyscraper takes place primarily in Asia and the Middle East. The competition began in 2008 with the Shanghai Tower, which is 632 meters tall, 3 times the height of the Montparnasse Tower, with 137 floors and 420,000 square meters of floor space. The Shanghai Tower has 107 lifts servicing the 18,000 people who pass through it every day. But even before the Chinese tower was completed, another skyscraper was on its way, the Burj Khalifa in Dubai. Emblematic of the giganticism and power of the Emirates, it smashed all records. Completed in 2010, it is 828 meters tall and weighs as much as 5 Airbus A380s. To ascend its 162 floors, it has 57 high-speed lifts. They travel at 36 kilometers an hour for a total of 1 minute and 22 seconds from the ground floor to the top. But that was without including Saudi Arabia, which has embarked on one of the largest construction projects in history with the Jeddah Tower. This tower will be over 1 kilometer high and should be completed by the end of 2020.
The Jeddah Tower is the tower of superlatives.
It's going to be the tallest tower in the world, over 1 kilometer high, 243,000 square meters with 315 flats, plus 200 hotel rooms. It also holds 15,000 people. It's a vertical city.
A vertical city equivalent to 3 Eiffel Towers stacked on top of each other. With 167 floors, it will house homes, offices, hotels, restaurants, shops, and entertainment areas. The largest lift network ever deployed will operate 24 hours a day in this record-breaking building.
In a tower of this type, it takes about 60 to 70 lifts to ensure efficient traffic flow.
These are lifts with the latest technology, the latest innovations.
But in order to build these lifts that can travel 1 kilometer high in one go as quickly as possible, the experts were faced with a major problem. The key element that allows the lifts to function and rise: steel cables.
When you move a lift car, you must never forget that not only are you moving the cabins and the users inside, but you are also moving the entire length of cable that connects the car to the machinery. And this length of cable, once it reaches around 500 meters, is so heavy that it becomes impossible for the engine to pull the whole cabin plus cable. And that's why we had to find a solution that would reduce the strain and the weight of the cable.
Today, in the world's tallest skyscrapers, builders are forced to deploy several lifts in relay to reach the top. Each cabin serves a maximum level called the landing. Users traveling to the higher levels have no choice but to change cabins once or multiple times. This is the case at the Burj Khalifa in Dubai or the Lot Tower in Seoul, South Korea.
The first lift will take you to the 50th floor. Then you'll change lifts there to go from the 50th to the 100th floor.
For the lifts in the Jeddah Tower, the manufacturers have opted for lifts with new technology.
The idea in the Jeddah Tower is to have a lift that will start from the bottom and go up to more than 800 meters high. It will be the highest lift in the world in one run, without having to change cabins.
To achieve this, the engineers embarked on a mission that would have been unimaginable a few years ago: to design an alternative to the traditional steel cable.
To go higher, we had to find a solution. We needed to find a strong and durable material to replace what has been used for 100 years, steel cables.
One of the world's leading lift manufacturers has set up its research center in a highly strategic and secret location in the heart of Finland's forests. Invisible from the outside, this unique laboratory is located in old limestone mines, hundreds of meters underground. For the first time, it opened its doors to our cameras. Looking like a secret base with high-tech facilities and lifts worthy of science fiction films, this research center has the highest inverted test tower on the planet. 350 meters underground, deeper than the Eiffel Tower would be if it were knocked down, it is known here as the Infernal Tower. A total of 11 shafts were sunk in the limestone mine over 1,600 meters deep to test the lifts. The 7 deepest ducts are dedicated to the design of equipment for high-rise buildings such as the China Zun Tower in China or the Tour First in La Défense, the highest skyscraper in France. We are 350 meters underground at the lowest level in the bowels of the laboratory. Domi Sibila is responsible for very high-rise projects. He leads the testing to develop the most extreme lifts in the world.
Let's go to check some components.
Okay, so now the material has arrived. So
these arrived yesterday.
Okay.
And now tomorrow we have planned to start to install these.
We dig deep to reach the sky. We go as far underground as possible to equip the world's tallest buildings.
Tallest buildings in the world.
In this hostile environment, all electronic and mechanical components are subjected to the most extreme conditions of use: freezing temperatures, humidity, extreme speed, and emergency stops. The aim is to develop the most innovative and reliable lifts in the world.
Well,
there is, of course, great competition to be the first to develop the best technology. That's why we work here underground with the highest security.
Confidentiality.
In this ultra-secret center, highly qualified engineers, technicians, and researchers have been working for years with a common goal: to free themselves from steel cables in order to climb higher, faster. And to equip the future highest tower in the world, the Jeddah Tower, which will reach a record altitude of 1 kilometer.
It was necessary to bring together all the material experts to define the best technology to meet the specifications. It took us more than 10 years to develop this brand new technology for use in the Jeddah Tower.
Of this rope. to be suitable for elevator application.
Working in partnership with suppliers and various industries such as automotive and textiles.
Dozens of engineers are mobilized both in the research centers and in the test towers.
This revolutionary technology was tested for the first time on this most powerful engine in the Finnish laboratory. It overlooks the inverted tower, which is 350 meters below ground. It is in this shaft that the lifts for the Jeddah Tower are tested and developed.
And you checked on how many?
10 meters per second.
10 meters per second is fine.
The cutting-edge technology that has taken engineers so long to replace the historic steel cable is here. It took 10 years of research and testing in this hidden laboratory to develop it. This cable is not round like its steel ancestor. It has greater elasticity and, above all, is much lighter. The engineers who developed it agreed to reveal this technological revolution already underway in the world of lifts.
It is a flat carbon fiber cable with an anti-abrasive surface.
These are highly friction-resistant materials that are 10 times lighter than steel. It will consume half the energy and will be twice as durable.
It also makes it possible to go higher and faster in comfort for the user, because steel cables have noticeable vibrations that carbon cables do not have.
With steel cables from a height of 300 meters, the cabin becomes less stable as it rises. It moves with the tower, particularly when it is windy, which causes the passenger discomfort. Carbon fiber stabilizes the lift like no other process before.
We've developed a unique technology. We're talking about a speed of 10 meters per second or 36 kilometers per hour to cover a kilometer. This was possible only a few years ago. This is truly an extraordinary innovation.
With this state-of-the-art technology, the Jeddah Tower's lifts will cover the greatest distance ever in the world. 1 kilometer in just 1 minute and 40 seconds. To reach these speeds, manufacturers have been extremely ingenious. Their cabin design is based on state-of-the-art aerodynamic technology.
We have a warhead profile that will really help the fluid, which is the air, to pass at high speed in the quietest and most optimized way. A bit like in the automotive world when we talk about air penetration. It's exactly the same phenomena that we have to handle with very high-speed lifts.
For some years now, engineers have been setting dizzying speed records in their test centers.
Today we have machines that can move at 70 to 90 kilometers per hour, so the speed of movement is controlled.
The speed reaches the record figure of 100 kilometers an hour for some manufacturers, but to date, none of these small vertical cars developed in the laboratories have been able to be put into service in a skyscraper. At stake, the human factor.
People can only be moved in a cabin up to a certain speed. Otherwise, they feel sick. It is essentially a problem of adaptation of the human body. At about 10 meters per second, a normal, healthy human being will start to have a real problem with the inner ear.
To meet this new challenge and exceed 36 kilometers an hour without affecting passengers, manufacturers have borrowed from aviation techniques to develop more efficient lifts.
Up to about 10 meters per second, i.e. 36 kilometers per hour, we will be working with normal cabins, and beyond that, we will be working with pressurized cabins.
Pressurization consists of maintaining the pressure inside the cabin at a constant level, regardless of altitude. The lifts in the tallest towers go up so fast and so high that the human body cannot cope with the sudden changes in air pressure. A pressurized cabin makes it possible to handle this phenomenon.
The same thing happens when you get on a plane and your ears get blocked. So we're going to pressurize the cabin so that people don't feel this pressure variation. The door will be watertight and will enclose the cabin so that it will not depressurize with acceleration.
Thanks to the pressurization of the cabins, the speed of the lifts has been increased by several tens of kilometers per hour. The record for the fastest lift in the world is held by the Shanghai Tower. These lifts reach speeds of 74 kilometers an hour and get to the top 600 meters higher in a lightning run of 53 seconds. Above this speed, it could endanger its occupants. And when it comes to safety at such heights, in the world's most used means of transport, the rules are very strict.
Lift safety is one of the most standardized areas in the world. There are pages and pages of regulations that are updated every year to ensure that lifts around the world are at the top of their safety game.
Accidents are rare in lifts, but when they do occur, they are usually very serious. To ensure the safety of their users, manufacturers plan for the most extreme situations.
The worst-case scenario is a cable break. It can happen, not that it never will, but today and for several years now, all lifts have been equipped with what are called parachutes. So the parachute is not a big canvas that will unfold. The parachute is a safety system that is compulsory and automatically blocks the cabin if the lift starts to go down too fast.
The parachute is activated in an emergency as soon as the cabin exceeds the usual speed. The metal jaws prevent the lift from free-falling even if the ropes break. This system is your life insurance inside the cabin and is therefore the most controlled by the engineers. In the ultra-secret test center of one of the world's leading lift manufacturers, where the cabins go up to 350 meters underground, experts test their future devices under extreme conditions.
The test consists of setting up a cabin launched at full speed at 65 kilometers per hour, on which we trigger the parachute systems to stop the cabin.
Everything is in place.
Yes. Today, Domi Sibila, who is responsible for high-rise projects, will be piloting what is known as a drop test.
The device is ready, in the right position. Everything has been set up for the test. Everything is in order. Here we are ready. And they are also ready in the control room, in front of the measuring instruments to start the test.
Are ready for starting the test.
In a few seconds, a disaster movie will be played out in the backstage area of the test center. The worst-case scenario for the engineers, a sudden cable break. A 10-ton cabin will be dropped into this 200-meter-deep test pit in free fall.
We're good here. You can run the test.
Roger.
The lift goes into overdrive and reaches speeds of 70 kilometers an hour. The cabin was saved by the parachute brakes. If you had been in such an accident, it would have saved your life.
These tests are carried out excessively regularly in real-life situations, which guarantees the reliability of the technologies that are implemented.
The invention of this brake system led to the birth of the modern lift. But the history of the lift began much earlier with the construction of the pyramids, where the first winches were used. Until the Renaissance, lifting systems multiplied, and in the 17th century new devices appeared to transport people, such as the surprising flying chair used in Versailles. A seat balanced by a counterweight and pulled by servants to allow Louis XV's mistress, Madame de Pompadour, to join the king in his flats. With the Industrial Revolution in the 19th century, vertical transport took on a new dimension. The invention of the parachute in case of cable breakage by the American Elisha Otis in 1853, the arrival of the electric lift, and later of electronics made the lift an avant-garde technology. The lift is becoming the most widely used but also the most tested means of transport in the world to ensure the safety of its passengers. Among all the disasters reproduced in the laboratory, one failure feeds the nightmares of manufacturers.
The most serious risk for a lift operator is to have an unlocked landing door without the lift behind it. This is the most significant danger for me that could happen.
We are in the Loirette in the town of Gien, a few kilometers from Orleans. This is where the world's leading lift manufacturer has its largest factory in Europe and one of its most important research and development laboratories with 130 engineers, 2 test towers and full-scale tests.
The first tests that are done are tests that are related to what the standard requires, the lift standard, but also tests to see what the level of performance is, speed, capacity to carry different loads, noise, vibrations, things like that.
While researchers work every day to improve their technology, 75% of the tests carried out at the Gien Center are dedicated to safety. This team will test the strength of the landing doors, reinforced by these steel arms that the manufacturer has just developed.
There is a box that has been added as reinforcement.
All right.
And the parts of the sill to prevent the sill from coming out of its guide.
Very good.
We try to reproduce accidents that may take place in everyday life. Someone with bad intentions who drives into the door, so we make sure that it can withstand this and therefore not weaken and open into the void.
We're going to drop a 45-kilogram weight from a height of 2.4 meters, which would correspond to the impact of a rugby player at full speed against the landing door.
If the door and the new steel arms can withstand the impact, these prototypes will be used in our lifts tomorrow.
Are we ready? Let's go.
To pass the test, the door must not be deformed by more than 12 centimeters. Only 4 centimeters deep and always locked, this prototype meets the highest safety standards.
The door has retained its integrity, so the door retains its full protection function.
With its state-of-the-art alloy, the door withstood the 45-kilogram load. It will be exported all over the world. While the landing door can be a hazard when open, in recent years it has become an important safety feature in buildings as a fire barrier. Today, in this laboratory, it is the function of the lift doors that will be put to the test during a full-scale test, unique in France.
The fact that the lift is finally in the heart of the building, beyond the transport aspect, it has an enormous safety role. And it's true that as the lift shaft, the vector by which fire can spread, the core must be made as safe as possible. The lift, therefore, becomes a safety element of the building.
Because of the cost and the significant resources involved, this test is carried out only once a year. To achieve this, a 5-ton concrete slab was poured in the laboratory. The engineers then built in this landing door.
The purpose of this test is to ensure that a fire on the landing does not spread through the door and reach the upper floors of the building. So it's really a test that allows the building to be saved in the event of a fire.
The concrete slab was mounted on a giant furnace that was brought to full power. Behind this door, the inferno will rise to a record temperature of 1,000 degrees. The aim is to push materials beyond their ultimate limits.
The temperature approaches 700 degrees after only 11 minutes.
All right.
We should see the door turn red within 15 to 20 minutes.
For 2 hours, the doors are tested with heat and flames. As the temperature rises, they turn red and become deformed. If no flames pass through the doors, the test will be considered successful.
The two things we are mainly interested in this test are, first, not having flare-ups that last longer than 10 seconds, and second, being able to calculate the carbon dioxide that passes through the door in the style of fire propagation. We were able to verify that there were no flames for more than 10 seconds. The leakage rate was measured, and it's correct. So this door passes. The test is conclusive.
A few meters from this test laboratory is the only lift manufacturing plant in France. A unique cabin has just been built. Back to the west of Paris in the first European business district, La Défense.
A tower in La Défense is a challenge for an elevator operator, as soon as you start working with an architect on the use of the floors. From then on, there are a lot of calculations, simulations that will be done, because without the dimensioning of the lifts, the design of the tower could not exist.
This brand new tower currently under construction is part of the renovation project of the La Défense district. The 150-meter high building is distinguished by a facade clad in glass scales. This was an unusual challenge for the manufacturer, who was charged with designing some 20 lifts.
It's 47 floors, it's 4,500 people. These people have to be transported in the morning for about an hour and at lunchtime for 2 hours. We say to ourselves, people should not wait more than 25 seconds.
Due to the limited space available in this business district, the tower has a flared shape. Thus, it offers a variation in floor area from 700 square meters at the foot of the tower to 1,700 meters at the top. In designing these lifts, the world leader had to meet two challenges: to create cabins that take up as little space as possible in the building in order to make the most of the floor space, and to transport as many people as possible in the shortest possible time.
We sat down with the architect, the general contractor and the promoter, and that's where the idea came from to switch from a classic technology that we see a lot of in La Défense called the single deck to a cabin in a shaft with a system called the double deck instead. We have two cabins, one on top of each other. We can move twice as many people in terms of transport capacity.
This hybrid lift, consisting of two joined cabins, is a first in France. At the head of this project is Fabienne Blanc. Today she will pilot the first ever launch of the first ever double cabin installed in the building.
So how does it look?
Not too bad for the moment.
The double-decker lift that we're installing today is a feat of technology. The two cabins are connected, they're 60 centimeters apart and systematically serve both levels at the same time. This system allows many more people to be transported and thus reduces travel times for users.
Both cabins will be accessible via two landings at the base of the building. One on the ground floor, the other on the upper level, served by an escalator. The lift will make its first test run, a crucial step because it is during this run that the cabin's brain will memorize its route and secure its future journeys. Before the launch, Nicholas, the technical manager, has to check all 42 floors of the 160-meter high tower.
I still have 15 levels to check at the doors and stopping details.
All right.
So I think in an hour we can consider doing the high-speed test.
In an hour, all right.
During this first test, the lift will identify each landing, the opening and closing times of the doors, as well as the highest and lowest levels to prevent it from crashing into its own shaft.
Each security element must be checked on the 160 meters, that each lock is correctly adjusted and that each magnet is correctly positioned to trigger the opening or closing of the door. This is done to the millimeter.
The test is controlled from the engine room at the top of the tower. These boxes above the lift shafts contain the thinking heads of the machines. They are capable of recording, storing and analyzing millions of pieces of data in order to ensure speed and safety for passengers.
So I'm good, my inspection is good.
Yeah. Here we go.
I usually have the sequence which works there.
Yeah, it stops at 37.
This first test is a success. In total, the tower will be equipped with 8 double-decker lifts, i.e. 16 cabins, which will transport 4,500 people every day.
The team is very proud. It's a beautiful project. It's a huge challenge in terms of time, logistics, complexity, but I think it will be a great success.
Despite all these technological innovations, there is one fear in our collective imagination that is as old as the lift: being trapped in the cabin.
Lift stress is a major issue. For many users, the ultimate fear is to be stuck inside with the possibility of claustrophobia or a very strong feeling of claustrophobia.
In France, each lift breaks down on average 3 times a year. Manufacturers are devoting large R&D budgets to make this moment as worry-free as possible.
In particular, thanks to the connected lift, which now makes it possible to have a live connection between a passenger who is stuck in the lift and an operator who can reassure and keep the passenger informed of the technician's response time.
We have a team specially trained to talk to users who are stuck in a cabin, to know what tone of voice to use, what words to say, to ensure that a user who is stuck has an acceptable experience by the time the technician arrives to get them out of the cabin.
Every year in France, nearly 150,000 people are trapped between two floors. The latest technological innovations are being used by all lift operators worldwide to combat this.
What we have deployed is a system, a display in the lift that allows you not only to hear the voice, but also to see the person in the call center. Having eye contact with the person completely transforms the experience, which is why we developed the product.
The manufacturers are going even further with a goal: lifts that are so efficient that they will never break down again. To achieve this, a revolution is underway with the latest emerging technology.
We are trying to make the lifts progressively more intelligent, and today we are clearly continuing to invest heavily in one area, namely artificial intelligence. We talk about artificial intelligence because man and machine progress together, and man teaches the machine to reason and analyze technical data.
It is in the area of maintenance that progress has been prodigious. A fantasy that was unattainable a few years ago is now becoming reality.
The dream of every lift engineer is zero breakdowns, and artificial intelligence will facilitate us moving in this direction.
This arrival of artificial intelligence in the world of service and construction is increasing rapidly today.
This small revolution is predictive maintenance. The ability to preempt a breakdown and to carry out all the necessary work beforehand.
Predictive maintenance consists of lift operators in installing a certain number of sensors on the lift, which makes it possible to know whether the lift is operating, moving at the planned speed, whether the doors open as planned, whether noises can be heard, and so on. So we record all this information in order to preempt possible breakdowns.
These connected sensors placed all over the cabs continuously measure the lift's operating parameters. The data collected in bulk is fed to an intelligent engine and is analyzed.
For example, the part of the lift that works the most is the doors. They open, they close, 7 days a week for decades. A standard opening and closing time is determined. And as soon as this opening or closing time is outside a set tolerance, an alert can be sent to a technician who can intervene on the lift and readjust the door, for example.
Solving a problem before it happens by predicting it. A scenario worthy of a futuristic film.
We're really in the predictive maintenance business. That is to say, we will prevent the problem. We will solve it before it becomes a breakdown. So zero breakdowns and zero accidents, of course.
This technology, known as predictive maintenance, is already indispensable for certain lifts, such as those located on the Aiguille du Midi site. Opposite Mont Blanc, 2 lifts take visitors to the roof of France. Their shaft was dug into the heart of the rock at an altitude of almost 4,000 meters.
The Aiguille du Midi lift is a unique achievement. The main difficulty was placing a lift in the rock of the Aiguille du Midi, and then being able to ensure the best maintenance conditions for the lifetime of the lift.
The Aiguille du Midi is one of the most visited tourist sites in France. Its summit terrace is close to the summit of Mont Blanc, and since 2013, a new attraction has been offering a breathtaking viewpoint, the step into the void. To access this breathtaking panorama, you have to go through the tunnel of the Central Piton. It leads to the lifts carrying you to the famous Mont Blanc terrace. They cover a distance of 65 meters without interruption from an altitude of 3,777 meters to 3,842 meters. These extreme lifts have been designed to withstand freezing temperatures as low as -20 degrees. They are also equipped against lightning and earthquakes. With more than 5,000 visitors per day, the site must be operational 7 days a week. On the eve of the season's opening, a team of helicopter professionals come to perform a high-flying maintenance operation. Their mission is crucial.
The Midi lift cannot break down for a very simple reason. The summit terrace has no access by stairs. The only access is the lift, so it has to work constantly. We will focus on the operator.
Agreed.
The two engineers head for the engine room, where the lift motors are located.
Preventive maintenance is carried out in such a way that the lift functions perfectly after the season. We'll start by checking the history and then focus on the operator. In the machinery, we have the so-called drive controller, which is the brains of the lift. It receives all the car orders, all the dispatches, and it manages all the safety devices. In fact, this controller has the capacity to record the defects it can see, and we use it as a guide for maintenance.
With the help of sensors installed at strategic points in the cabins, the two experts were able to identify weak points that could lead to a breakdown. They will therefore be able to modify the settings in a preventative manner for optimal operation of the equipment.
This is the lift in the area that has the highest traffic and will therefore use its landing door the most when opening and closing. So today, we're focusing on the cabin door to make sure it's set up properly, so that when we start the season in a few days, everything will be operational.
This preventative maintenance is carried out under extreme conditions. At an altitude of almost 4,000 meters, every gesture is calculated, every effort saved.
Breathlessness, concentration is impaired, work is more difficult. Anything that would take us an hour anywhere else will take us 3 hours here.
The first lift was created in 1996. Initially, there was only one. It was replaced in 2015 by this duplex lift. At the time, these major works were known as the Vertigo Works.
We acclimatized our staff. Our fitters were given training at altitude so that they'd be able to work for a long time and over a long period of several months at altitude. A company came to dismantle the lift. A company specialized in rock removal came to widen the shaft.
A job done by blasting the granite. A total of 8,000 boreholes were drilled to place the micro-explosive charges. A titanic undertaking carried out for one purpose.
As there's a 65-meter run with a door at the top and a door at the bottom, if they're blocked in the middle at 30 meters, how are we going to look for them? We use the cabin next door, which is on the same level. We open the hatches and the people go from the cabin that's stopped to the cabin that's in operation so that we can evacuate them.
This season, 500,000 visitors are expected to visit the Aiguille du Midi site. If today our lifts are intelligent without us even noticing, manufacturers are developing devices in their laboratories that will be increasingly connected and interactive in the future.
The lift of the future is certainly a lift that you can't see, that is something intuitive and communicates extremely smoothly to meet needs. Tomorrow's lift will recognize you, it will know where you're going, and it will take you there effortlessly.
Traveling in these new lifts will no longer mean being cut off from the outside world. From an experience of disconnection, they will become places of hyperconnection with our environment.
We are able to have interactive walls on which we are able to consult social networks, consumption choices that the user will be able to have at his disposal when he travels.
Buttonless lifts with facial or digital recognition and personalized screens like in this lift in Finland, the first in the world to be connected to social networks. But progress will not just be in the interaction between man and machine.
The lift of the future will be a very energy efficient or even autonomous lift. It will recycle its own energy.
We will be able to recover the energy from the lift's braking system when it reaches the ground floor and turn it into electricity to power the whole building.
We will arrive at self-learning lifts that are even more intelligent and aware of what is going on around them.
But there is an even more revolutionary lift that has been in development for 3 years in German laboratories. A real lift that for the first time in its history will operate without its 160-year-old technology. The cables.
Every day since 2015, you have cable-free lifts running in our test tower in Rottweil, Germany.
This test tower is located in the middle of the countryside in southeastern Germany. It is 246 meters long. Engineers there have developed a revolutionary lift that allows devices to move through buildings by magnetic levitation. These small cabins move over the tracks. The device does not touch the walls of the guide rail.
This system is 2 magnets that repel each other, the cabins that have magnets and the shaft that has magnets. So the shaft and the cabin will never touch. The cabin levitates, so we have a cabin that doesn't need cables.
This process allows the cabins to move vertically as well as horizontally by means of electromagnetic tracks oriented by a rotating switch system. It is no longer a simple lift shaft, but an internal network. In this configuration, the multi-lift looks like a metro in the heart of your buildings.
Describing this cable-free lift is also describing the city of the future. This cable-free lift allows us to invent all possible and imaginable forms of towers with interconnecting towers. That's why it's also interesting for a number of architects. It allows you to think differently.
These lifts will lead to new ways of traveling in completely redesigned cities.
We can imagine that tomorrow we will no longer have cars in cities, but we will have multis that will allow us to travel from home to the office without having to make a journey by car. Finally, we're going to make the user travel within the city while remaining in a single cabin, which is the multi.
The cable-free lift is currently under construction on a building site in Berlin, Germany. The very first model is expected to go into service in a few months, but this is just the beginning.
Today, this technology is perfectly mastered within our group. We have 15 concrete projects around the world where we are working with architects to implement this cable-free lift. We will bring out the cable-free lift and it will be marketed from 2022-2023. So the city of the future is tomorrow.
With the growth of megacities and population explosion, the race for height is one of the major challenges of our century. As a key technology for the city of the future, the lift will contribute to the upheaval of our lives, as it did 150 years ago when it allowed the construction of the first megalopolises on our planet. What started out as a simple cabin pulled by scrap metal cables is becoming the main vehicle towards a new world.